Welcome back to Algebra 2, Topic 37, Natural Logarithms. This is Part 2, and in Part 2 we're going to practice expanding natural logarithmic expressions. So when asked to expand, we want to think about our properties. So here we have ln of x to the sixth, y to the third. Well, what do we notice first? What operation do we see? We see that there's multiplication in this argument right here. So we know with multiplication that this translates to addition with logarithmic properties. So we have ln of x to the sixth plus ln of y to the third. Now we have one more step before we're done expanding this. We also note that we have exponents here, so we can use the power property. We can bring my exponents out front and get 6 ln of x plus 3 ln of y. Moving on to the next example, ln of the cube root of u, v, w. Now what I first want to think about is what is another way that I can rewrite this. Maybe using an exponent. Well, we know, thinking about rational exponents, when we're using the cube root, this is basically the same thing as taking ln of u times v times w and raising it to the 1/3 power. Because whenever we don't see an exponent, there's automatically a 1 there. What we're going to do now is use the power property. So we're going to bring our exponent out front and get 1/3 times ln of u times v times w. Now it's really important to identify that we have multiplication right here because that's going to come in handy in one moment. Now I'm going to focus on this part right here, expanding. Very similar to what happened with number 1, when we see multiplication, that's going to translate to addition with logarithms. So I have my 1/3 times, this translates to ln of u plus ln of v plus ln of w. Now this 1/3 is times this entire quantity. So I could distribute it. I could get 1/3 ln of u plus 1/3 ln of v plus 1/3 ln of w. Now another way that I could write this would just be ln of u divided by 3 plus ln of v divided by 3 plus ln of w divided by 3. Moving on to the next example. Again, this is a reminder that we're dealing with expansion, so we want to expand this. I know at first glance it might be really simple to just want to evaluate this, but I'm going to have you restrain yourself. So what do we notice here? Well, we have ln of 5 squared divided by 2 to the 5th power. Now a lot of people would want to do, okay, well 5 squared, that's 25, divided by 2 raised to the 5th power. Well, I can simplify that. But our notes here tell us that we want to expand. So in order to expand, what I'm going to do is I'm going to take this power and distribute it to both the numerator and the denominator. So thinking back to my properties of exponents and ignoring this ln right here. So I would get ln of 5 squared to the 5th power over 2 to the 5th power. Now when I have a power raised to a power, I want to multiply my exponents. So I would get ln of 5 to the 10th power divided by 2 to the 5th power. Now here, what operation do I see? I see division. So that translates to subtraction when I'm dealing with logarithms. So this would give me ln of 5 to the 10th power minus ln of 2 to the 5th power. Now here, I have one more step when I'm asked to expand. I have my exponents right here, so I can move them in front. And I would end up getting 10 times the natural log of 5 minus 5 times the natural log of 2. And that's your answer. Thank you for watching.